Okay, so this should be very straightforward, because everybody on the first day was able to do a good job of this, and then I wasn't able to really look at what you were doing last time. But, I would assume that this grid, which just adds a line here and a line here to this one, and one more line down here. And this grid, which we explained last time, and maybe I'll go over that since I didn't really get to explain it to you. Okay. So if this is the origin, and this is 4x4, then I know this point over here is -2, 0. That's the point in the corner. And this point in the upper right-hand corner is 2, 4. Now that's, we went over that last time. Okay. If this is the origin, then this is where actually 0. If this thing's 4 units wide, that means it goes 2 units on either side of the origin, 2 units on either side of 0, giving you the point -2, 0 and the point 2, 4. And remember also a week ago, we went through all the details of labeling all the construction lines. So that's something that I would hope that you had practiced considerably where it's automatic and where you automatically see it. Okay, because we're going to start doing algebra with these things. You don't understand the numbers, it's going to be harder to understand what comes next. So make sure that you really understand everything we've done so far. It's just pictures and understanding the coordinate plane. Okay, in a way, you probably never had to understand it before, but it's very fundamental. Okay. You really need to do that, so make sure you follow up on that. Then for this table, I'm not going to label these construction lines because it takes time and we've already done it. But what line would this be? Y equals what? Show me some fingers. Okay. Y equals 2. Because this is Y equals 4 up here. Why is this Y equals 4? Because Y equals 0 at the origin. And this thing is 4 units high. Okay. So process that as much as you need to make sure you really understand it. Okay. So this is a line, x equals 2. That's our Y equals 2. What's the value of x on this line? 1. X is 1 on this line. So that's the point where x is 1 and y is 2, right? So in your table, you have the point where x is 1 and y is 2. Now, if leaping through these papers, see that probably, and I just sampled about half of them, but it looks like it's running a little better than 50-50 in favor of people getting these right. Okay. But then there are a lot of them that don't have any correlation to this scheme. Okay. So I don't know who did what. I wasn't looking at names, I was just looking at numbers. Okay. Make sure that real quickly you're among those who gets these right. Okay, so we understand why 1, 2, right? Okay, well, what's the x value on the left edge? The left edge. Okay, so -2. Okay, everywhere on this line here, -2. I want to know because this point is on that line. Okay, and what's the y value on this construction, horizontal construction line? Not 0. 0 is down here at the corner. This is not at the corner. Okay, so it's, well, let's worry about this first. Okay, so the x value here is what? horizontal line, x equals what? Well, you got 4, you cut that in half, you got 2, you cut that in half, you got 1, right? What do you get when you cut 1 in half? You get half. What do you get when you cut a half in half? You get a fourth. Well, you have to understand that. Okay? Fractions are not something you punch into a calculator and get the answer, don't understand. Okay? So you really want to process that idea. If somebody gives you $1 and asks you to give them change in quarters, how many quarters are you going to give them? I hope everybody knows it's 4. Maybe nobody's, you might not ever had to have change. You know, got a bunch of change in my pocket. It's starting to get heavy. I'm starting to get tired of carrying it around. Have to find some place to spend it. Where do you get to spend cash? Hey, hand somebody cash, it looks like you like you're crazy. Okay, well, anyhow. So again, at this point, x is -2 and y is a fourth. Again, we labeled that. Make sure you review this stuff. If you didn't totally understand it last, look at the videos again. You don't have to watch every word or everything in the video, but the parts you didn't understand, you should isolate and really make sure you understand them. Okay, so anyhow, there we have it. Well, bottom line, x is -2, y is a fourth, x is -1, y is a half, x is 0, y is 1, x is 1, y is 2, x is 2, y is 4. Ask yourself the question, which horizontal line and which vertical line am I on? Okay. The horizontal line start up here at 4, halfway to 0 is 2, halfway to 0 from there is 1. You see, the vertical lines are even much easier. You got 0 here, you got -2 here, you got 2 there. Okay, well, same scale on this one, except you got an extra line. And the only reason that extra line is there, if you remember, is you have to, your rule is over 1 down 2. Okay. So once we're here, it would have been the last line on this one. We mark a point, and then we have to have this line here to skip, so we end up with red dot. Okay. Well, there we have it. X values again are -2, -1. Then we have a -1/2. We have 0, 1/2, 1, and 2. Now, right, those are pretty small. There's a lot of room. But our y values are 4, 1, 1, 4, 0, 1, 4, 1, 4. Now, I saw some papers that had the 4, 1, 0, 1, 4, didn't have the 1, 4. That 1, 4 is real important. It tells you how low you got to go so that you get the right shape of curve. Okay. And it certainly is one of the points you mark if you do the algorithm. Okay. Over here. Now the red dot is here. This is the point 0, 0. This point is -2, -2 down here in the corner. It's not a label. And this point up here has to be 2, 2. And I probably shouldn't put an X there. So I use X for the structure points. But just orient, you know, of course, that's 0, 0. So what do we have? Well, up here, y is 2. Down here, y is -2. On the left, y is -2 everywhere on the left boundary, and y is 2 everywhere on the right boundary. Now we start at the line just below the center line. Now remember how these lines are constructed. After we draw the center line, let me actually I don't think I've actually constructed this one live for you because I gave you the instructions last time. I saw that people seem to be doing pretty well. But let's be sure we understand the construction of this. Now, the first thing is we do the same thing we did with squaring function. We do the squaring function, like we start with the exponential function, that puts this line, this there. And each one of these lines is twice as close to the center as the one before. So we start here, we go halfway to the center, there we are. And then we go halfway to the center from there. On the left, we start at the left and go halfway to the center, which is here. And then halfway to the center from here, which is here. Well, we do the same thing with horizontal lines. There's our center. Now we start at the top and go halfway to the center. And then we go halfway from there to the center. That's it. And the top. Then from the bottom, we go halfway to the center, which is here. And then halfway to the center, which is here. It's not completely accurate, but that's the idea. Then we figure out what the lines are. Okay? You know, this line here is x equals -2. This line here is x equals 2. This line here, x equals 0. Now halfway from -2 to 0, we get the line x equals -1. And halfway from there to the center, we get x equals -1/2. Okay? So you should understand that it takes, I just said, I said it's four when you did it, but you should understand how to do these anytime. Okay, so from here to here, this is 2, and we're going halfway to 0, so this that'll be x equals 1. And then halfway between 1 and 0 is 1/2. So you should be able to draw that and label your lines in a minute or less. You don't have to be, if you want to be really meticulous, it can take you a long time. Okay? But you know, slot down a graph, that's kind of slot down. It's not totally accurate, but it's accurate enough to show us what we need to see right now. All right, then for the horizontal lines, well, this is the line y equals 0. Here's the line y equals 2. Here's the line y equals -2. Okay, so this line is halfway from the top to the middle, which is halfway from 2 to 0, and that's the root point. And this is halfway from 1 to 0, which is 1/2. And similarly, this is -1/2, and this is -1. Now we label our points. Or in the algorithm, you start left edge just below the center, and you get this point, and you go right one, down one, right one, down one, and you're done on this side. And of course, you draw the, and then you start on the first horizontal, first vertical line to the right of center, and you take the mark, and then you go over one, down one, over one, down one, and you have that part of it. Okay. Now, if you haven't practiced that until you can do it quickly and label it, do that. It won't take you that. You practice for an hour, you're going to have it. Okay. And you should have done that by now. And many of you probably did. A lot of you probably understood it, didn't even need to practice. But if you weren't able to come in here and do this and get these tables, which looks like at least a third of the class wasn't able to do, so you got a lot of company. Okay, practice. These things are fundamental. I'm going to use them again and again. Can't be tripping over it. Okay, and it's not hard. Again, nothing conceptually difficult about it. It orients you to the plane. It orients you to coordinates, to horizontal and vertical lines in a way that you're going to need in order to understand what comes at you kind of fast starting next week. Okay. Okay. So now if you want to make a table of this thing, Okay? And what's this? It said x equals -2 and y equals -0.5. -2, -0.5. And you have x equals -1 for this line, and y equals -1. So you got -1, -1. And there you got x equals -2, y equals, sorry, x equals -0.5, y equals -2. And there are the rest of your values. Okay. Now, I think this thing, try to be a little bigger so everybody can see it. Actually, I take it back. I don't want to do this yet. I don't want to do that one yet. We'll do this. Okay. What arithmetic operation could I do for each of these numbers, the same operation? Like, okay, let's suppose I double each one of these numbers, okay? Well, if I double -2, do I get 4? No, if I double -2, I get -4. Okay? If I double -1, do I get 1? No, well, if I double a negative, I don't get a positive, right? If I double 0, do I get 0? You got 2 zeros, that adds up to 0. If I double 1/2, do I get 1/4? No, if I double 1/2, I get 1. If I double 1, I get 2. If I double 2, I get 4. This one actually works with doubling, right? But doubling it isn't the rule here. So is there some operation that I could do each of these numbers that would give me these numbers? That give me all of these numbers? Okay, well, I got a good suggestion. We could square the numbers. Now, it said, if you square -2, you get 4. You square -1, you get 1. You square -1/2, you get 1/4. You square these numbers without using your calculator. Calculator is totally inappropriate for squaring these simple numbers. And if you don't know how to square fractions, you need to know how to square fractions, so learn how to square fractions. Okay? And if you don't, email me their exercises you can do. Simple exercises take you 20 minutes. Okay? Open math type stuff. Stuff that I've assigned to my intermediate algebra class. Okay, square -2, that's -2 times -2. Okay. Two negatives make a positive. 2 times 2 is 4. I know you know. Okay. Won't bother with -1, but -1/2. Or it was -1/2 times -1/2. You multiply the numerators, to say numerator is -1, -1 times -1 over 2 times 2, because that's how you multiply fractions. If you don't know that, again, that's a terrible indictment of our education system. But you gotta know that. So review the fractions if necessary. Okay, and that's where you go 1/4. And the rest of them are pretty straightforward. Obviously, you know, 0 by itself, you get 0. So this is your quadratic. Or for squaring function. It's kind of small. We call it the squaring function because that's what it does to the x values. Okay. If you construct it, now you have to believe that this is a construction of the squaring function. Because the table you get from the points you use to construct it give you a table for a squaring function, right? Every one of these numbers is a square of this number. Every number in the y column is a square of a number in the x column. So now we can say that this is y equals f of x equals x squared. If you don't know what f of x means, you will by Monday because there's an assignment. Okay. Open math will tell you. I'll tell you something. Okay. It's simple enough. Okay. Now, the rule for this. Anybody want to suggest what that rule might be? Don't be afraid of being wrong. Yeah, I'm a little bit shocked that people don't understand the word reciprocal. I don't know how you do algebra 1 without understanding the reciprocal. But maybe they're using different. I'll have to ask. Okay. I find it kind of disconcerting. Still, this is the reciprocal function. That's what we called it. Reciprocal means flip it over the one divided by the number. For example, if x equals 2, y equals 1 over x, which is 1 over 2, right? So, well, right there, we got the line that tells you that, right? All right. Okay. Now, how do you do 1 divided by 1/2? When you have something over a fraction, that means that thing is divided by the fraction. Means you invert this thing and multiply. And you get 2 in this case. Okay. Now you see that in this one. Okay. And you can get the rest of them. Got one over -2. Well, 1/-2, you put the negative in the whole thing, you get -1/2. That should be obvious. If not, write it out. Get yourself through some, because you have to understand these operations. Among other things, because in about 6 weeks, you're gonna have to do these operations with symbols. And if you don't understand them with numbers, you're not gonna be able to do them with symbols. So you have to understand fractions. I will probably email you. Probably not too long after class. And tell you where to find an exercise with that. I think I've got it in the book from there. But I haven't assigned it, but I'm going. Okay. Simply have to be able to deal with fractions. You have to be able to deal with numbers. That's part of it. Okay. Okay, here we got the exponential function. You got the numbers, it's okay to exponential function. That's what you do. You draw this picture and you write down the numbers. And then you verify that the calculation works. Calculation involves property of exponents that almost nobody ever knows when they come out of high school. Okay? First row of the table. Simplest table of all. Notice I almost wrote 0 there because I was thinking a lot of people want to write 0 for that, and then I did it. Just thinking 0, so I wrote 0. Okay. Now, that was the Y, but you know the thing. It's almost like a G. Paper, so everybody. Fancy Y, but that's not very good. Okay, Y equals 2 to the X. Now, so here, Y equals 2 to the -2. Now, how is that 1/4? Well, it's because of what a negative exponent means. 2 to the -2 means 1/2 to the 2. The negative on the exponent puts it in the denominator. Okay? There's a good reason for that. I'm not going to try to explain it right now, but of course, that's 1/4. If x equals -1, y equals 2 to the -1, which is 1/2 to the 1. Let's make sure that's is 1/2. And then y equals 2 to the 0, which equals 1. Why does 2 to the 0 equal 1? Because the rules for exponents wouldn't make sense, didn't. Okay? Also, this graph wouldn't make sense if 2 to the 0 wasn't 1. We can use this graph to define 2 to any power. Okay? Any whole number or integer power. And because of this graph, 2 to the 0 has to equal 1. Because when x is 0, x equals 0. y equals 1. Two to the one is just 2. 2 to the second power is 4. Those are the calculations. Okay. Okay, so again, what I've done here is I marked 4 points, and through each point I have a horizontal and a vertical line. Position of the vertical line tells you the x coordinate of that point. Horizontal line tells you what the y coordinate is. I've labeled the construction lines. Y equals 1/4, 1/2, 125. I want to call that 0.25, 0.51, because you're probably going to estimate decimals instead of fraction. Okay. Got that. So I want you to estimate the x and the y coordinate of each of these points. Okay, so what you would want to do, calculator, I'm going to ask you to do this with a calculator at home. Okay. Plug in 1.5 for x, so you do 2 raised to the 1.5 power. Every calculator, that's probably like 2 raised to the 1.5 equals whatever the sequence of buttons in your calculator is, okay? And you use this thing to raise the power. Well, 2 raised to the 1.5 power. I'm going to make my own list, but I think it's 2.828. Actually, I know it's 2.828, of course, in different figures. Because of something that everybody, I like a prep course in my high school, knew in such a way I could never forget. Okay, which is what the square root of 2 is, of course. Okay, I know. Okay, it comes out 2.828. Now, is that what you're saying is that according to this graph, you estimate that it should be 3. Okay. So 2.828 is very darn close to 3, isn't it? So 1.53 is probably a pretty good estimate. That's a little less than 3, but the graph is real precise. Okay. So I'm going to ask you to make estimates, then use your calculator to verify them. Okay. And there are a couple of other things, a couple of other buttons you can push. And right now they're just buttons. To answer certain other questions. Okay, now the assignment you're going to have in Open Math, I'll give you an assignment to work with your graphs, okay? And not particularly hard, doesn't really take long once you get the gist of making estimates. Bunch of numbers in your calculator. I want you to understand what these graphs are telling you. Okay. I want you to understand the numbers so you can see the numbers. You don't have to see them with great precision. You just have to see that this number should be this precise. Okay. But I want you to really understand these graphs in that way, numerically and in terms of coordinates and so forth. Okay. Now, what you have is a function. Open Math is going to explain to you what functions are. Okay. A function is just something that you can give one number to and it gives you another number. So I'm asking you, if I give you the number of 1.3, could you draw the line for x equals 1.3? And then could you estimate what the y coordinate of that is? Well, by the time you finish all the assignments, you will. We difficult, all it takes is a little practice, okay? So you're the machine. I give you the number 1.3. You go to the graph and you make your estimate. You say, okay, I think that's about 2.7. That's the output. Okay. Now, if you go to your calculator and ask it what this function is for 1.3, it'll give you a big long answer that's very precise. Not completely accurate, but it's accurate in a lot of decimal places. Okay. So your calculator operates on functions, it gives you outputs. You give it an input, it gives you an output. The rule for this function is 2 to the x. Okay. There are a bunch of ordered pairs. We could write a set of points on this function as a set of ordered pairs. Okay, that's a function. Matter of fact, I'll say, clarify a little bit. The domain of this function is -2, -1, 0, 1, 2. The set of numbers, set of x values we use for construction points, isn't it? So the domain is your set of x values. The range is your set of y values. So that's what a function is. Sometimes you got a formula for the function. Sometimes you got a graph that defines a function. Sometimes you can have a set of ordered pairs that defines the function. Okay. In every case, there are inputs and outputs. The inputs are your domain. The outputs are your range. That's a pretty succinct statement of what a function is. And see, we have different functions. We have the reciprocal function, which could be designated for one of the graphs. Okay. Now, I want to give you a quick, function notation. F of x equals x squared. I should make that up. Okay. F of x equals x squared. So F of 3 equals what? Somebody want to show me with the fingers? Well, you don't need that. If I gave you a bigger number, you wouldn't have enough fingers. Okay. What does F of 3 mean? Well, F of x is x squared, right? X has been replaced by 3. If you replace x by 3, then you better replace this x by 3. And this tells you what it is, 3 squared, and that's 9. Okay? Make sense? What's F of -5? Well, now x is -5, so you write -5 wherever you see x. And you calculate it, right? What's F of A. Well, here's your rule, f of x equals x squared, so if you got a instead of x, f of a equals a squared, right? See the pattern? What's f of a plus b? Well, now you gotta be careful, because a lot of people want to say a squared plus b squared, which isn't right. Okay? X is a plus b, so the whole darn a plus b has to be squared. Okay? Make sense? Pretty simple. It's just a way of talking about functions, giving them names. And sometimes they're functions, well, you give them names that you're not allowed to repeat. Okay, some folks will just say first. We won't get into those. Okay, does that all make sense? Okay, you should be in pretty good shape for the homework. If you want a more extensive introduction to the idea of functions, I did one in the MDE 61 early on. Okay. Now, Open Math will introduce you to the tooltip functions, but we've already got 3 of them. And you see, you don't need numbers to define them, but you can put numbers on them. Okay. Open Math thinks that all you do is calculate, you never understand anything. Okay. So I want you to understand it a little more deeply, but that's why we started. Okay. Have a good weekend. Stay healthy.